What's going on, everybody? We're back. We're back. We're back. Anthony here, Friendly Neighborhood Geeks. We are following, for those who just tuned in for the first time on this video, I think it's part 6 on this one. We are going through freecodecamp.org's YouTube channel. They have a AWS certified cloud practitioner section on there. We also have a book that we bought off of Amazon with the objective of taking this test, the certification test, May 2024. So it looks like today we're starting off with the AWS toolkit for VS Code, which is where we left off prior to on part 5. So let's get into it.
And sometimes you can view them, sometimes you can delete them. It's going to vary per service and what's available there. Then you have the AWS CDK Explorer. This allows you to explore your stacks defined by CDK. Then you have Amazon Elastic Container Service, ECS. This provides IntelliSense for ECS task definition files. IntelliSense means that when you type, you'll get like auto completion, but you'll also get a description as to what it is that you're typing out. Then there is serverless applications, and this is pretty much the main reason to have the AWS Toolkit. It allows you to create, debug, deploy serverless applications via SAM and CFN. And so there you can see the command palette, and you can kind of access stuff there, okay?
That was fast. Easy install.
Let's take a look here at access keys. So an access key is a key and secret required to have pragmatic access to AWS resources when interacting with the AWS API outside of the AWS Management Console. So access key is commonly referred to as AWS credentials. So if someone says AWS credentials, so you generally are talking about the access key, not necessarily your username and password to log in. So a user must be granted access to use access key. So when you're creating a user, you can just checkbox access key. You can always do this after the fact, but it's good to do that as you're creating the user. And then you can generate an access key and secret. So you should never share your access keys with anyone. They are yours. If you give them to someone else, it's like giving them the keys to your house. It's dangerous. Never commit access keys to a code base because that is a good place for it to get leaked at some point. You can have 2 active keys at any given time. You can deactivate access keys, obviously delete them as well. Access keys have whatever access a user has to AWS resources. So, if you can do it in the AWS Management Console, so can the key. So access keys are to be stored in the AWS credentials file. So, and if you're not familiar with Linux, this tilde here, this actually represents your home folder. So whether you're on Windows or a Linux, that's going to be your home folder. And then you have this period AWS. That means that it's a hidden folder, but you can obviously access it. And so it's just a TOML-like file. I think it's TOML, but I never 100% verified that it's TOML. It looks just like TOML. And so what you'll have here is your default profile. And so this is what you would use, or this is what any of your tools you use, like the CLI or anything else, would automatically use if you did not specify a profile. You can, of course, store multiple access keys and then give it a profile name. So if you are doing this for the first time, you might just want to type in AWS config and it'll prompt you and you'll just enter them in there as well. I think that sets the default one. When you're using the SDK, you would rather probably use environment variables because this is the safest way to access them when you are writing code. All right. So there you go.
And he showed us that export. That's how you store variables on Linux.
All right, let's talk about
Global
access
variables.
keys. Access keys are very important to your account. And so what we'll do is go to IAM. If you are the root user, you can go in and you can generate access keys for people. But generally, you're doing it yourself for your own account. So I go to users. I'm going to click into mine here, and we'll go over to security credentials. And here, you're going to notice access keys. And one thing that is interesting is that you can only ever have 2 access keys at a time. So if I hit create, I'm just going to close that. Notice that the button is grayed out. I can deactivate them if I feel that I haven't used them in a while, and I can make them active again, so I can bring them back into access. Or what I can do is make them inactive, right? And then I can delete them. And so what I recommend, right, even if you do not want to pragmatically be using your account for anything, you always want to fill up both these. And the reason why, and this is for security reasons, is that if somebody wanted to come in and get into your account, what they would do is they would try to find a user where they have access to them, and then they would try to generate out a key. So if both these keys are taken up, so if you generate out both these keys, okay, and this is the one you want to use, you deactivate the other one, okay, we're not going to use that one. And so now there's no way for them to fill up that other slot, okay? And so that is my strong recommendation to you, but there's, again, only ever two here. I'm just going to delete both of these so that when we want to do whatever next in a tutorial, we'll go generate that out, okay? So I'm going to go ahead and clear that out. So hopefully that is...
I don't know if there's an API way to generate
access keys,
an access key.
So I'm going to go back here.
But we're not guaranteed that that would stop at just two keys if we're using an API.
Let's take a look here at AWS documentation, which is a large collection of technical documentation on how to use AWS services, which we can find at doc.aws.amazon.com. And so this is kind of like the landing page where you can see all the guides and API references. If you expand them in there into EC2 and you click on the user guide, you can see HTML in PDF format, Kindle. And you'll notice there's a link to GitHub, and that's because all of these docs are open source and you can contribute to them if you choose to do so. I've done so multiple times in the past. It's quite fun. So AWS is very good about providing detailed information about every AWS service, and the basis of this course and any AWS certification will derive mostly from the AWS documentation. So I like to say that I'm not really coming up with new information. I'm just taking what's in the docs and trying to make it more digestible. And I think that's the thing is like, the docs are really good. You can read them end to end, but they are very dense. And so it can be a bit hard to figure out what you should read and what you should not. But they are a really great resource, and you should spend some time in there, okay? So I just want to quickly show you the AWS documentation, like give you a bit of a tour of it. So if we go to aws.amazon.com and type in docs, and I'm sure you might have seen this through other tutorials, but the idea is that you have basically documentation for basically any possible service that you want. And a lot of times you'll click into it, and what you'll get are these little boxes, and they'll show you different guides, and it's going to vary based on service, but a lot of times there's a user guide, there's an API reference, and those are the two that you'll see there. Maybe we go to something.
I'd like to point out that it looks like they've taken down the GitHub option. And I would just off the top of my head presume when Microsoft bought GitHub, they probably thought that was a conflict of interest and took it off. I could be wrong. They could still be accessible from a GitHub.
Simpler like S3. That might be a simpler example. Yeah, user guide, API reference. And so all of these are on GitHub, right? If you open these up, the documentation is here. If you find something you don't like, you can submit issues and correct things. You can even submit your own examples. I have committed example code to the docs specifically for AI services. So you might be looking at examples that I implemented, or even Ruby examples, since I really like to promote Ruby on AWS. And you can download it as a PDF, or you can take it as HTML. A lot of times you're going to the user guide, and the way I build the courses here is I actually go through and I read these end to end. So, you know, if you wanted to do that and you want to be like me, you can do that, or you can just watch my courses and save yourself the trouble and not worry about everything that is here. But generally, the documentation is extremely, extremely good. There are some exceptions like Amazon Cognito where the content is good, but it's just not well organized. So I would say AWS, out of every other provider, they have the most complete documentation. They generally don't keep their examples or like tutorials within here. It's usually pretty light. They'll have some examples, but like they like to have AWS Labs separately. So you type AWS Labs GitHub, right? You go here, and a lot of stuff is in here instead. So you have a lot of great tutorials and examples over there, okay? But yeah, pretty much that's all there is to it. Is there consistency between documentations? No, they kind of vary, you know, but it's all there is my point. And they're always keeping up to date. So yeah, that's all you need to know about the AWS documentation. Hey, this is Andrew Brown from Exam Pro, and we are taking a look at the shared responsibility model, which is a cloud security framework that defines the security obligations of the customer versus the cloud service provider. In this case, we're talking about AWS, and they have their own shared responsibility model. It's this big ugly blob here. And the thing is that every single CSP has their own variant on the model. So they're generally all the same, but some visualizations make it a little bit easier to understand, or they kind of include a little bit more information at different parts.
Let's stop it here and just digest this real quick before he goes in it. So when they say responsibility model, if you are hosting services in a cloud infrastructure or cloud service provider's infrastructure, your local government, maybe even state or federal, may have certain laws on storing different types of data, customer data, um, in the Electronic Information Act that you have to abide by. And so AWS is saying, here's what we cover when you choose us. We make sure that you have regions and edge locations, and we provide a database. We provide the compute power, the storage, and the networking. Everything else from network traffic protection, like DDoS attacks, um, things like server side encryption for files like SQL injection. You're responsible for, whitelisting runners and all that good stuff. Data integrity, backing up copies and encrypting that. So passwords and things like that. Um, Choosing the operating system. That means not just choosing the operating system, applying updates to that operating system and security patches. Same thing with network and firewall configuration, making changes to that. Limiting identity access management to applications. And again, that big one at the top is you are responsible for every aspect of that customer data that you're storing or accessing. Because if someone else who's not authorized gets access and leaks that data online, you're still responsible for that.
Parts of it. And so just to make sure that you have well-rounded knowledge, I'm going to go beyond the AWS's shared responsibility model and just show you some variants. There's also variants not just per CSP, but also the type of cloud deployment model. And sometimes these are also scoped based on a cloud service category like compute or machine learning. And these can result in specialized shared responsibility models. So that's what we'll look at in this section, okay? All right, so let's take a look at the AWS shared responsibility model. And so I've reworked the graphic because it is a bit hard to digest. And so I'm hoping that this way will be a little bit easier for you. I cannot include the in and of here just because we're limited for space, but don't worry, we'll follow that up with the next slide here. So there are two people that are responsible, or two organizations that are responsible, the customer and AWS. And on AWS's side, they're going to be responsible for anything that is physical. So we're talking about hardware, global infrastructure. So the regions, the availability zones, the edge locations, the physical security. So think of all that hardware that's there, those data centers, everything like that. Then there's also software, the services that they're offering. And so, this extends to all their services, but generally it breaks down to the four core. And so we're talking about compute, storage, database, and networking, okay? And when we say networking, we're talking about like physically setting up the wires and also, the software to set up the routing and all that kind of stuff there. Now, looking at the customer side of it, they're responsible for configuration of managed services or third-party software. So the platforms they use, so whether they choose to use a particular type of OS, the applications, so if they want to use like Ruby on Rails, IAM, so identity and access management. So if you create a user and you grant them permissions, if you give them things they're not supposed to have access to, that's on you, right? Then there's configuration of virtual infrastructure and systems. So that would be choosing your OS. That would be the networking. So there could be networking on the virtual machines themselves, or we could be talking about cloud networking in this case. Then there are firewalls. So we're talking about virtual firewalls. Again, they could be on the virtual machine, or it could be configuring like NACLs or security groups on AWS. Then there's security configuration of data. And so there is client-side data encryption. So if you're moving something from S3 from your local machine to S3, you might need to encrypt that first before you send it over. Then there's server-side encryption. So that might be turning on server-side encryption within S3 or turning encryption on your EBS volume. Then there's networking traffic protection. So, that's turning on VPC flow logs so you can monitor them, turning on AWS guard duty so that it can detect anomalies with your traffic or activities within your AWS account. And then there's customer data. So that's the data that you upload on the behalf of your customers or yourself, and what you decide to, like what levels of sensitivity that you want to lock it down. Do you want to use Amazon Macy to see if there's any public-facing personally identifiable information? That's up to you. So there's a lot here, and honestly, it's a lot easier than you think. Instead of thinking about this big diagram, what I do is I break it down into this. And so we have the in and the of, and that's what I said I could not fit on the previous slide there. But the idea is customers are responsible for the security in the cloud. So that's your data and configuration. So if it's data that's residing on there, or is there something you can configure, you are responsible for it. On the AWS side, they are responsible for the security of the cloud. So if it's anything physical or hardware, the operation of managed services or global infrastructure, that's going to be on them. And this in and of thing is very important for the exam, so you should absolutely know the difference between the two. This is kind of an AWS concept. I don't see any other cloud service provider talking about in and of, so you definitely need to know it, okay?
Good. There we go. We're finally getting into some meat and potatoes here on testing.
One variant we might see for the shared responsibility model would be on the types of cloud computing. This could also be applicable to the types of deployment models, but we're doing types of cloud computing here. And so we have the customer's responsibility and then the cloud service provider's responsibility. So we're seeing on-premise, infrastructure as a service, platform as a service, and software as a service. And so when you are on-prem, you're basically responsible for everything: apps, data, runtime, middleware, OS, virtualization, servers, storage, networking, basically everything. And just by adopting the cloud, you're almost cutting your responsibilities in half here. So now the cloud service provider is going to be responsible for the physical networking, the physical storage, those physical servers. And because they're offering virtual machines to you, they're setting up a hypervisor on your behalf. So virtualization is taken care of for you. And so, if you launch an EC2 instance, you're going to have to choose the OS. So that's why you're responsible, whatever middleware there, the runtime, so whatever kind of programs you install on it, the data that resides on it, and any kind of like major applications, okay? Then we have platform as a service. And so, the cloud service provider is going to take even more responsibility there. So when we're talking about this, we're thinking like AWS Elastic Beanstalk, right? So, you just choose what you want and it's all managed. So you might say, I want a Ruby on Rails server, but you're not saying what OS you need. You're not saying you might say what version of Ruby you want, but you don't have to manage it if it breaks, or it might be managed updates and things like that. The last thing here is like software as a service. And this is something where the CSP is responsible for everything. So if you're thinking of a software as a service, think of like Microsoft Word, where you're just writing, writing stuff in there, and you are responsible for where you might choose to store your data, but the data is like still handled by the cloud service provider because it's on the cloud, so on their servers, right? So yeah, hopefully that gives you kind of an idea across types of cloud computing responsibilities. All right, so what I want to do here is just shift the lens a bit and look at the shared responsibility model if we were just observing a subset of cloud services such as compute. And so we're going to see infrastructure as a service, platform as a service, software as a service, and now we have function as a service. And so that's what I mean. When we shift the lens, we get new information. And so you can just see that you really don't want to look at this from one perspective, okay? So starting at the top here, we have bare metal. And so AWS's offering is called the EC2 bare metal instance. And this is where you basically get the whole machine. You can configure the entire machine with the exception of the physical machine itself. So as the customer, you can install the host OS, so the operating system that runs on the physical machine. And then you can install your own hypervisor. And then AWS is going to be responsible for the rest, the physical machine. Now, normally the next step up would be dedicated, but dedicated doesn't exactly give you more responsibility. It gives you more assurance because it's a single tenant virtual machine. And that's why I kind of left it out here. But we'll see it in the next slide that it is kind of on the model and shares the same spot as EC2. But EC2 is a virtual machine. And so here the customer is responsible for the guest OS. So that means that you can choose what OS you want, whether it is Ubuntu or Debian or Windows, but that's not the actual OS that is running on the physical machine. And so you're not going to have control of that. AWS is going to take care of that. Then there's the container runtime. So, you can install Docker on this or any kind of container layer that you want. So that's another thing that you can do. So AWS is going to be responsible for the hypervisor, the physical machine, and the host OS. All right. Then looking at containers, AWS has more than one offering for containers, but we'll just look at ECS here. And so this is where you are going to have you don't install the guest OS, right? The guest OS is already there for you. What you are going to do is choose your configuration of containers. You're going to deploy your containers. You're going to determine where you need to access storage for your containers or attach storage to your containers. And AWS is going to be responsible for the guest OS. And there might not even be a guest OS, but the host OS, the guest OS, the hypervisor, the container runtime, and you're just responsible for your containers, okay? Then going to the next level here, we have platform as a service. And so this one also is a little bit odd where it fits because the thing is that this could be using anything underneath. It could be using containers. It could be using virtual machines. And so that's where it doesn't exactly fit well on a linear graph, but let's just take a look at some things here. So this is where you're just uploading your code. You have some configuration of the environment. You have options of deployment strategies, the configuration of the associated services, and then AWS is going to be responsible for the servers, the OS, the networking, the storage, the security. So it is taking on more responsibility than infrastructure as a service, whereas, AWS is just going to be responsible for that. So if it's a virtual machine that's being under the use, then AWS is going to be responsible for this customer stuff. Okay, you're not. If it's containers, then AWS is going to be responsible for this, but it just depends on how that platform as a service is set up. Actually, the way Elastic Beanstalk is set up is that you actually have access to all that infrastructure and you can fiddle with it. And so in that case, whereas like if you were to use Heroku, which is a third-party provider, they would take care of all this stuff up here. And so you would not have to worry about it. But on AWS, you actually are responsible for the underlying infrastructure because you can configure it, you can touch it. So that's where, again, these do not fit perfectly. And you can't look at platform as a service, meaning that you're not responsible for certain things. It really comes down to the service offering, okay? Then we're taking a look at software as a service. So on AWS, this is going to be something like Amazon WorkDocs, which is, I believe, a competitor. Not a very popular competitor, but a competitor to Microsoft SharePoint. This is for content collaboration. So as the customer, you're responsible for the contents of the document, management of the files, configuration of sharing access controls, and the AWS is responsible for the servers, the OS networking, the storage, the security, and everything else. So, if you use a Microsoft Word doc and you type stuff in it, you say where to save it, that's what you're responsible for, okay? The last one here on the list is our functions here. And so AWS's offer is AWS Lambda. And so as the customer, all you're doing is you're uploading your code, and AWS is going to take care of the rest. So deployment, container runtime, networking, storage, security, physical machine, basically everything. And so you're really just left to develop, okay? So, hopefully that gives you kind of an idea. And again, we could have thrown in a few other services. Like what we could not fit on this slide here was AWS Fargate, which is a serverless container as a function, or sorry, serverless container as a service, or container as a service. So, that has its own unique properties in the model as well, okay? So let's just have kind of a visualization on a linear graph here. So we have the customer's responsibility on the left-hand side and AWS's responsibility on the right. And we'll look at our broad categories. So we got bare metal, dedicated, virtual machines, containers, and functions. And so no matter which type of compute you're using, you're always responsible for your code. For containers, if the functions, when you're using functions, there are pre-built containers. So you'd say, I want to use Ruby, and there's a Ruby container, and you don't have to configure it. But obviously, when you are using container service, you are configuring that container. You are responsible for it. For virtual machines, you're responsible for the runtime,
I'm
so you
not
can
quite sure why
install
he
a container
relisted these
runtime
at the
on there or
top.
install a bunch
I
of
mean,
different
I get the
packages like Ruby and
orange
stuff like
is
that. The
AWS,
operating
but
system you have control over in the virtual
maybe
machines
we're
for the
just trying to
dedicated.
pound
And
in
we
these
saw with bare metal, you
names
have
of
both
the different
controls of
AWS
the host OS
services.
and the guest
EC2,
OS. And then only bare
Beanstalk,
metal allows you to have control of the
Fargate, Lambda.
virtualization where you can install that hypervisor. So hopefully that gives you an idea of compute and AWS's offering there, and also kind of how there's a lot of little caveats when we're looking at the shared responsibility model, okay? All right, so I have one more variant of the shared responsibility model, and this one is actually what is used by Google. So we're going to apply to AWS and see how it works. So let's just kind of redefine shared responsibility model, or just in a slightly different way so we fully understand it. So the shared responsibility model is a simple visualization that helps determine what the customer is responsible for and what the CSP is responsible for related to AWS. And so across the top, we have infrastructure as a service, platform as a service, software as a service. But remember, there's other ones out there like function as a service. It's just not going to fit on here. Okay, so and then along the side here, we have content, access policies, usage, deployment, web application security, identity, operations, access and authentication, network security. Remember, that's cloud networking security, the guest OS, data and content, audit logging. Now we have the actual traditional networking or physical networking, storage and encryption, and here we're probably talking about the physical storage, hardened kernel, IPC, the boot, the hardware, and so then here we have our bars, so we have the CSP's responsibility and the customer's responsibility. So when we're looking at a SaaS software as a service, the customer is going to be responsible for the content. Remember, like think of like a word processor, you're writing the content, the access policies, like say I want to share this document with someone, the usage, like how you utilize it, can you upgrade your plan, things like that. Then next on our list here is platform as a service. So generally, platform as a service is for developers to develop and deploy applications. And so they will generally have more than one deploy strategy. And, there might be some cost saving measures to choose, like you might have to pay additional for security, or it's up to you to configure it in a particular way, or you might have to integrate it with other services. And we saw that PaaS is not a perfect definition or fit because, when we look at Elastic Beanstalk, if you have access to those resources and you can change them underneath, then you might have more responsibility there than you think that you would, okay? The next one here is infrastructure as a service. And so this is extending to identity. So who's allowed to, log into your AWS account, operations, the things that they're allowed to do in the account, access and authentication. Do they have to use MFA? Things like that, network security. Obviously, you can configure the security of your cloud infrastructure or cloud network. Do you isolate everything as single VPC? How do you set up your security groups? Things like that. We know with virtual machines, you can set up the guest OS. There's data and content. But remember that bare metal is part of the infrastructure as a service offering. And so that's where we'd see hardware, or not hardware, but you'd have the host OS or virtualization. And so this, again, is not a perfect representation, but it generally works, okay? And then last on the list there, or just looking at what the AWS is responsible for audit logging. So, of course, AWS has CloudTrail, which is for logging API events. But audit logging could be things that are internally happening with those physical servers. Then the networking, the physical storage, hardening the kernel. AWS has, I think, what's called the Nitro system, where they have like a security chip that's installed on all their servers. Then it's the boot OS, and then the hardware itself, okay? So just remember, the customer is responsible for the data and configuration of access controls that reside in AWS. So if you can configure it or you can put data on it, you're responsible for it, okay? The customer is responsible for the configuration of cloud services and granting access to users via permissions, right? So if you give one of your employees access to do it, even if it's their fault, it's your fault. So remember that. And again, the CSP is generally responsible for the underlying infrastructure. We say generally because, there's edge cases like bare metal. And coming back to AWS's in the cloud and of the cloud. So in the cloud, so if you configure it or store it, then you, the customer, are responsible for it. And of the cloud, if you cannot configure it, then the CSP is probably responsible for it, okay?
Ooh, here we go. Meet and potatoes. I'm loving
Hey,
it.
this is Andrew Brown from Exam Pro, and we are looking at the shared responsibility model from the perspective of architecture. And if you're getting sick of shared responsibility model, don't worry. I think this will be the last slide in this section, but let's take a look
We're
here.
okay.
So
Give it to us.
we have less responsibility, more responsibility at the bottom. So what we have down here is traditional or virtual machine architecture. So global workforce is most familiar with this kind of architecture, and there's lots of documentation frameworks and support. So maybe this would be using Elastic Beanstalk with Platform as a Service, or using EC2 instances alongside with auto-scaling groups, code deploy, load balancers, things like that. The next level here is microservices or containers. This is where you mix and match languages, better utilization of resources. So maybe you're using Fargate, which is serverless containers, or Elastic Container Service, or Elastic Kubernetes Service for containers. And at the top here, we have serverless, or commonly with functions as a service. So there are no more servers. You just worry about the data and the code, right? So literally just functions of code. And so you could be using the Amplify serverless framework, or maybe AWS Lambda for creating serverless architecture. So there you go.
EC2.
Hey, this is Andrew Brown from Exam Pro, and we are looking at computing services. And before we jump into the entire suite of computing services AWS have, let's just talk about EC2 for a moment, which allows you to launch virtual machines. So what is a virtual machine? Well, a virtual machine, or VM, is an emulation of a physical computer using software. Server virtualization allows you to easily create, copy, resize, or migrate your server. Multiple VMs can run on the same physical server, so you can share the cost with other customers. So imagine if your server or computer was an executable file on your computer, okay? So that's the kind of way you want to think about it. When we launch a VM, we call it an instance, and so EC2 is highly configurable server where you can choose the AMI, so the Amazon Machine Image, that affects options such as amount of CPUs or vCPUs, virtual CPUs, the amount of memory, so RAM, the amount of network bandwidth, the operating system, so whether it's Windows, Ubuntu, Amazon OS2, the ability to attach multiple virtual hard drives for storage, so Elastic Block Store. And so the Amazon Machine Image is a predefined configuration for a VM, so just remember that. And so EC2 is also considered the backbone of AWS because the majority of AWS services are using EC2 as the underlying servers, whether it's S3, RDS, DynamoDB, or Lambdas. That is what it's using. So when I say also, it's just because when we talk about the AWS network, that is the backbone for global infrastructure and the networking at large. And so EC2 is for the services, okay? Hey, this is Andrew Brown from Exam Pro. So we just looked at what EC2 is. Well, let's look at more of the broader services for computing. And these are the more common ones that you'll come across. There's definitely more than just what we're going to see on this single slide here. So we'll break this down with virtual machines, containers, and then serverless. For virtual machines, remember, that's an emulation of a physical computer using software. And EC2 is the main one. But for our VM category, we have Amazon Lightsail. This is a managed virtual server service. It is the friendly version of EC2 virtual machines. So when you need to launch a Linux or Windows server, but you don't have much AWS knowledge, you could launch a WordPress here, and you could hook up your domain and stuff like that. So this is a very good option for beginners. We have containers, so virtualizing an operating system or OS to run multiple workloads on a single OS instance. So containers are generally used in microservice architecture when you divide your application into smaller applications that talk to each other. So here we would have ECS, Elastic Container Service. This is a container orchestration service that supports Docker containers, launches a cluster of servers on EC2 instances with Docker installed. So when you need Docker as a service or you need to run containers. We have Elastic Container Registry, ECR. This is a repository of container images. So in order to launch a container, you need an image. An image just means a saved copy. A repository just means a storage that has version control. We have ECS Fargate, or just Fargate now. People are kind of forgetting that it runs on ECS these days. That's why I have it in there. It is a serverless orchestration container service. It is the same as ECS, except you pay on demand per running container. So with ECS, you have to keep a EC2 server running, even if you have no containers running. So AWS manages the underlying server, so you don't have to scale or upgrade the EC2 server. So there's the advantage over ECS, okay? Then we have Elastic Kubernetes Service, EKS. This is a fully managed Kubernetes service. Kubernetes, commonly abbreviated to K8, is an open source orchestration software that was created by Google and is generally the standard for managing microservices. So when you need to run Kubernetes as a service, then we have serverless category. So when the underlying servers are managed by AWS, you don't worry or configure servers. So AWS Lambda is a serverless function service. You can run code without provisioning or managing servers. You upload small pieces of code, choose how much memory, how long you want the function to run, is allowed to run before timing out, and you are charged based on the runtime of the serverless function rounded to the nearest 100 milliseconds. So there you go. Hey, this is Andrew Brown from Exam Pro, and what I want to do is just show you a variety of different computing services on AWS. So I'm going to try to launch them, and we're not going to do anything with them, just going to simply launch them, okay? So the first I want to show you is EC2. And by the way, we will go more in depth in EC2 later on in this course here. But what I'm going to do is go ahead and launch the instance. Don't worry about all this stuff, but just choose the Amazon Linux 2 so it's in the free tier. All right.
Let me pause this real quick. So he doesn't really cover this, but I just discovered how to do it. So when you come up to the search and you start typing in things like S3, you have the ability to click the star and add everything to favorite. But doing so didn't update your dashboard. I mean, you could see your recently visited, but if you come over to add widgets, there you will see where favorites was listed there. I just dragged it into my dashboard, right? So now anything that I have that I think I'm going to be using multiple times will be right here at the tip of my fingers.
We're going to choose an instance type of a T2 micro, so that's part of the free tier. It's going to be set as 1. All these options are fine. I want you to go ahead and review and launch. We're going to launch, and I don't want to generate on a key pair. I'm going to proceed without a key pair. I'm going to acknowledge that because I don't want it. And that's all there is to launching an EC2 instance. And so I can go here and view my instances, and what you'll see is it's pending, okay? And usually it has like a little spinning icon. Maybe they've updated it since then. So I go here. It's hard to see because there's all these terminated ones, but I don't need to do anything with it. I just wanted to show you the actions that you'd have to do to launch it. Actually, we'll leave it alone. Maybe we'll see it when it's launched. The next one I want to show you is Elastic Container Service. And wow, this is old. Let's get the new experience, please. It's so old. Okay, checkbox that on, and we'll hit get started, and we'll say create a cluster. And we have some options here: networking only, EC2 Linux plus networking, for use with either AWS Fargate or external Windows. This is if you're doing Fargate, which we're not doing right now. Fargate is part of Elastic Container Service. It used to be. It is called ECS Fargate, but AWS markets it as a separate service. We'll go to next and say my ECS cluster. We can create an empty cluster, but that would make it a Fargate cluster, which we don't want. There's an on-demand server. Look, it's M6I large. If you're very afraid of a lot of spend here, you don't have to do this. You can just watch me do it and just learn. Well, what I'm going to do is try to find something super cheap. So I want a T2 micro or a T3 micro. T2 micro is part of the free tier. I don't know if we get to choose T2 anymore in here. They might not let you. There it is. You know, T3 micro is great too. Whatever says it's free, that's what I'm going to go for. Number of instances 1. The Amazon Linux version is fine. I don't care about a key pair. Use the existing VPC. I don't want to have to make a new one. Select the existing ones, okay? Let it create a new security group. That's totally fine. Allow those to be fine. Create a new role. That's fine. Create. Okay. And so that's going to create ourselves a cluster. I'm going to just make a new tab here. Let's just check on our EC2 instance. And so if we look at our EC2 instance, it is running. Okay, great. So it has a private IP address. It has a public IP address. All right. There's not much we can do with it. I can't even log into it because we didn't generate out a key pair. A lot of times you want to name these things. So I can just go here and name it my server. Okay. We go back to our ECS instance and the cluster is ready. So we'll go here and oh, nice. We got a new UI. And so if we wanted to deploy something as a service or a task, Um, we would need to create a template, like a task definition file. They don't have a new UI for this. You're being redirected to the previous version console because this isn't available in the new experience yet. Of course it isn't. So we can create a new task definition file. That's what's used to run it. It's basically like a Docker file, compose file, whatever you want. We have Fargate or EC2. We are doing ECS, so we're going to have to do EC2. So we'll say my ECS task def file. Task role, optional IAM role. I don't need one. Network mode, I don't care. And then this is the idea is that because a container allows you to use up a particular amount of the thing, we don't have to use all of the memory. So we should look up what a T2 micro is because I don't even remember what size it is. Okay, T2 micro, AWS. So we go here, we look at the instance types, and we're going to flip over to T2, and it says that it's 1 vCPU, 1 gigabyte of memory. So what I'll do, 1? Yeah, 1. Okay, that's fine. So what we want, and this is in megabytes, so we'll say 500 megabytes. And I don't know if we can do less than 1, but I'm going to do 1 here. The task CPU must be an integer greater than or equal to 128. Okay, fine, 128. Oh, I guess it's 1024 would utilize the whole thing. So I could say 512, okay? And this is where we would add our container. So I don't do this every day, so I don't remember how to do this. We'll say my container, and I need a repository here. So I need like Docker
Looks like
hub,
Docker.
hello
That looks
world.
like a Docker image. Yeah.
Okay.
It's literally a
what
Docker
it is.
compose he's pulling up.
That's simple. And I'm
Docker
looking for
pull.
the address here. I'm hoping that it's just this. Docker hub URL. So it'd be something like this, right? Docker IO probably. Docker IO, Docker image, Docker hub URL in ECS. Okay, it goes to show how often I'm launching these things. So repository URL, Docker image. So I think that what we're going to do here, I would really just like the URL, please. Reviews, tags. Where is it? Where is it? It's somewhere here, right? Well, let's just try it. We'll go and we'll type in, it says image and tag. So docker.io, hello world. I really need an image ID. Image URL, hello world, Docker hub. They're not making my life easy here today. Anything. I just want to see like a single example. Docker.io. Docker.io URL examples. ECS. This is what it's like, you know? This is what you're going to be doing if you are, you know, a cloud engineer. You're going to be Googling a lot and just trying to find examples here. So here it says Docker.io, the name, the host name. Okay, so we'll just try it. Okay, so I think that the name here is underscore and then it's hello world, and that's what's throwing me off here, right? Docker.io. Just hold on here. Repository URL, and then there's the tag. I don't know if like, is the tag gonna be like latest, view available tags? Latest. Okay, so what I'll do here, and that's the thing, you have to have a lot of confidence too. So hard limit, soft limit, do I have to set it? Do I have to set any of these things? Can I just go to the bottom and hit add? Looks like I can. Okay, so we'll scroll on down, create. We create our task definition file, which is fine. We're going to go back to our cluster. It's going to bring us back to the new experience. We're going to click into this cluster. Holy smokes. We're going to hit deploy. And we are going to choose service. That means it's going to continuously run. Task means that when it's done running, it ends. We're going to choose our family, our version. That's the task definition file there. It's not compatible with the selected compute strategy. My task file. What if I just choose task? We'll take that. Okay, maybe some you have to like code it so that it continuously runs. I don't care. We don't need to run a service here. The selected task definition is not compatible with the selected compute strategy. Okay, let's see why. Can you double check if you're using Fargate strategy instead of the EC2 blog designed for the EC2 strategy? So probably what it's suggesting is that the strategy file I made is not for the right one here. Task definitions. Go back over here. Well, what's wrong with it? Task role, none. My container. So what I'm going to do, because I don't trust this, I'm just going to go ahead and delete this. Can I delete this? How do I delete this? Oh boy. Actions, deregister, deregister. We'll create a new one. And so AWS has tools like AWS Copilot CLI to make this a lot easier, because you can see this is very frustrating, but I chose this. So my task def requires compatibility of EC2 default 512 512 add container. We're going to what was it, docker.io underscore, what's it called, hello world.
Container name, come on, guy. Should just
Latest.
be hello world.
We'll just say hello world here. And we'll just say 512.
It's trying to validate if it's a legit image.
I'm just reading it carefully here to see what it wants. We'll say 512. Maybe because I didn't specify them, it's complaining. This looks fine. We'll hit add. Okay. Constraints, type. This all looks fine. So we'll try this again.
Did you pick restart unless stopped?
So we now have our file. Let's see if we can just run this task from here. EC2. This is just another way to do it. So we just choose the cluster. This is actually a lot easier to do it. This is old, eh? This is ugly. And so now it launches. So, you know, if you have trouble one way, then just do it another way. And sometimes it'll work here.
Pending.
So I don't expect this task to really work in any particular
if
way.
The right
if
image.
It's pending, that's fine. If it fails, that's fine. If it's successful, that's fine. I don't care. I just want to go through the motion. So it was successful. It ran and then it stopped. I don't know if we could see like the output anywhere. Probably what it would do is it would log out something like into somewhere. And so I don't know if like there's logs turned on for this. If I go over to like CloudWatch logs, maybe I could see something. A lot of these services will automatically create CloudWatch logs. So sometimes you can just go look at them there. So we'll drop down. We'll go to log groups here. There is some stuff here. There's a couple that I created from before. Just go ahead and delete those. And so what I'm looking for is like ECS. So no, there's no logging happening here, which is totally fine. So that is ECS. For Fargate, it's pretty much the same. The difference is that Fargate is like it has to start up and run, so it's a lot slower to watch. Okay. And now let's go take a look at Lambda. Okay. So this is our serverless compute. So we'll go ahead and create ourselves a function. We can start from a blueprint. That doesn't sound too bad. And I personally like Ruby, so no, I'm not getting much here.
Monster.
What we can do
Ruby
is look for something like hello. Do we have like a hello world? There we go, hello world. And we'll click that. We'll say my hello world. It's going to create those permissions. That's fine. It's showing us the code. It's very simple. Okay. It's going to console log out these values. Not a very good hello world function. Doesn't even say hello world. How can you call it a hello world function if it doesn't say hello world? I don't understand. So we're going to go ahead and create this function. Usually doesn't take this long. Okay, so here is our function. Here is our code. Notice that this is Cloud9. Okay, and you can even move that over to Cloud9. They didn't have this button here before. That's kind of cool. I hit test. They used to have it up here, but I guess they wanted to make it more obvious, so they moved it down here, which is nice. So what I can do is hit this. Oops, my test. And it's going to send a payload here to the actual function, and it's going to tell us if it worked. Okay, so can I run my test? We go over here to test. They changed it a bit. So I guess I created it there. It succeeded. So I have my logs. Okay, so it's going to output those values there. So there are the 3 values, which basically is nothing. Maybe you were supposed to set those in environment variable, but you can see you're just uploading some code, right? It's just a bit of code. It's not like a full app or anything. So we launched an EC2 container. We did an EC2 instance, a container. We did a serverless function. There's other things like EKS, but that is really, really hard to set up.
Yeah.
Okay, because you'd have to use like Kubernetes commands and stuff like that. And my Kubernetes knowledge is always very poor. I'm just taking a peek here to see if they've updated it. So yeah, you create the cluster, but like deploying it is, forget it. I'm just trying to think if there's anything else I kind of want to show you. No, those are the main 3, I would say. So I'm pretty happy with that. What I'm going to do is go and kill all these things. So we're going to go over to Lambda. Okay.
Unlive.
And I'm going to go ahead and delete this.
Harsh word.
And as you saw, ECS was the hardest. And no matter how many times I've built things on ECS and I've deployed full things on ECS, I can't remember. And I always have so much trouble with task definition files. It's unbelievable. We'll go over to our cluster here. And ECS cluster up here. Make sure you're not in the Fargate cluster. I know I'm clicking really fast, but there's just so many things to click. And I'm going to click into this cluster. We're going to go hit edit, because this is running an EC2 instance, right? I need to destroy it.
Or it's going to cost you money.
It just took me back to the old one here. I want to delete the cluster. Click back here.
There is no deleting the cluster.
Where do I delete it? Up here? Here? I can't checkbox anything. How do I
edit at
delete
the top?
This? Do I have to delete the task first, maybe? So we'll go here. I mean, it's already stopped. There's nothing to do. Edit.
You
Count
are
settings?
Stuck with it.
Wow, this is confusing. Okay. How to delete ECS cluster.
I think I saw it on that page.
You gotta be kidding me. I have to actually look this up. So open the ECS console from navigation. In the navigation, choose clusters. In the new, turn off new ECS experience and choose the old console. The delete cluster workflow is not supported in the ECS console. Are you serious? Then why do you have it? Like, why even let people use the new experience if you don't have all the functionality there? Oh, I was going to give it feedback, but it didn't let me. Here it says, I need to delete an ECS cluster. No.
You have to switch back to the old layout
here,
to be able to go in and
there's
delete.
my big ugly cluster. Delete cluster.
That's
okay.
Funny.
So yeah, it's a struggle. Okay, like things are always changing on me, but you just have to have confidence. And if you've done it a few times, you know that you can do it, right? And that's one of the biggest hangups to cloud, I would say. So it's going to take a few minutes apparently to delete the cluster. As that is going, let's go over to EC2. I didn't close it. I kept this tab open. And there's our EC2 instance. We can go ahead and terminate that instance. Terminate. Okay. And if this says it's terminating, then we're in good shape. Terminating or shutting down, that's fine. And notice here, that's the ECS instance. Just make sure you shut down the my server, not the ECS instance, because that's going to stop. And so this is already terminated. But if we go back here, notice that it says that it's not done, but it clearly has shut down. Okay. So I'm going to wait here for a bit, even though I know it's been deleted. Maybe it's deleting things like the auto scaling group. So we go down below here, right? So that's probably what it's doing. It's probably trying to destroy the auto scaling group. but it doesn't show any here, so it must have already destroyed
Yeah.
it.
Where do you see that?
Yeah, so task services delete. So I'll be back here in a bit, but I know it's safe. It's already deleted, but I'll see you back here in a bit, okay? So I waited literally a second, and it's now deleted. So we deleted our Lambda. We deleted our... Oh, did we delete our Lambda? Good question. Now, I'm not really worried about the Lambda because... I guess we did, but I'm not really worried about it because, you know, when it rests at idle, it's not costing us anything, where the ECS and the EC2 are backed by EC2 instances, so we do have to shut those down, okay? And again, remember, make sure you're in the correct region. Sometimes that gets flipped over, and then you think those resources are gone, but they're actually not. They're just running in another region. So there you go.
Okay. 55 minutes in. I think this is a great stop point. We covered 3 big ones today. He didn't get too into the weeds, but we touched on Lambda, which you just run your code and then it computes it for you, spits something out, and then it's done running. He also went into the ECS, Elastic Container Service, and he also ran an EC2 service, and then shut him down. I think on his Docker, I think he had the image URL a little incorrect there to pull the image from Docker. Not quite sure why he didn't have one on standby ready to run and rip before he recorded, but it happens, right? Shoot from the hip. For those of you who somehow managed to skip by the intro, Anthony here for Friendly Neighborhood Geeks. We are following the freecodecamp.org YouTube online video for AWS Certified Cloud Practitioner, with the end goal that we are going to attempt to take that certification May 2024. We've also purchased the book from an Amazon retailer. Yeah, so we're just doing about 2 hours a week. Tuesday we do an hour, Thursday we do an hour, and we upload those videos to YouTube. So if anyone's interested in following along and potentially trying to get certified in 2024, hit the subscribe button, follow along. The link to this video that we're watching through free Code Camp will be in the description. So I'm not trying to take creative licensing away from the people who've already created this content. All right, I'll see you guys back here later.